Welcome to Section 4.2, the case of the missing diagram. The objective of this lesson is to organize information in and draw diagrams for problems presented in words. So for our homework, we're going to be working on page 178 to 179, numbers 6, 8, 11, and 12. This lesson is going to be slightly different. There's not going to be any answers at the back, just because we want to make sure that we're working our way through really good. Alright, so it's important to know, for all of the proofs in this section, you're going to need to draw a picture based on what the proof says. You're not going to have any picture supplied whatsoever. You're not going to have any given lines. You're not going to have any proved lines. All you're going to have is kind of like a word problem. I know, everybody's favorite, but that's what we're going to see in here. Okay, so let's practice one together. Now for this one, all we're going to do is set up the givens, the conclusion, and draw the picture. So here's our problem. What we're going to try and do everything for is this statement. The medians of a triangle are congruent if the triangle is equilateral. So we have to kind of think about what we know and what we're trying to prove. So we're going to start off with our givens and our proof. And we need a picture. Now, first and foremost with our picture, we know we're going to have one triangle. Let's call this triangle EQU for equilateral. Now, we know we're going to have medians. So let's draw medians from each vertex. Let's make that an I. Let's make that an L. And let's make that an A. Now, let's work off those givens and prove. What we're talking about again, the medians of a triangle are congruent if the triangle is equilateral. So what information is going to be known? It's going to be the if part. So what's given to me first and foremost is that triangle EQU is equilateral. Now, what are we trying to prove? That those medians are congruent. Now, we have to know their medians to begin with. So those are going to be other givens. We're going to have EA is going to be a median to QU. We're going to have that QL is a median to EU. And we're also going to have that UI is a median to EQ. So then, what are we going to prove? Let's move this down a little bit. We're trying to prove that those medians, EA is congruent to QL, is congruent to UI. And that's what we got. Now, if you guessed, this isn't going to be an easy process. We really have to look at those words. We really have to see what's given to us and really determine what are we trying to prove here. So in the next slide, we're actually going to work one all the way through. The givens, the conclusion, the picture, and then the proof to follow. Okay, so let's try and write the statements and work through the proof. So here's what we have. The altitude to the base of an isosceles triangle bisects the vertex angle. So here's what we have. We're going to need to write down what our givens are, what we're trying to prove, and draw out a picture. Well, the one thing that I do know is that I'm definitely going to have a triangle. That triangle is going to be isosceles, so me personally, I'm going to call those corners IS and O. Now, we also know that I have an altitude to the base. Now, if my altitude is to my base, one thing that I know is that this piece right here is going to be my base, and my altitude is going to be going straight down here. So let's make this point right here C. Now, stuff that's given. Starts off, I know. Triangle ISO is isosceles with base SO. I also know that I have an altitude. I know that IC is an altitude to SO. what I'm trying to prove is that the altitude bisects the vertex angle. So here's what I'm trying to prove. That IC bisects angle SIO. So now we got it. Our givens, our proof, our picture. Let's read it through one more time and make sure it makes sense. The altitude to the base of an isosceles triangle bisects the vertex angle. We have an isosceles triangle. We know its base. We know we have an altitude. We're trying to show that the altitude is also an angle bisector. So here we go. Statement and reasons. Starts off with those givens. So here we go. Triangle ISO is isosceles. With base SO. And let's restate this. There we go. We also know that IC is an altitude to SO. Those are going to be my givens. Now, let's go ahead with that proof. We know that IC is congruent to IC. The reason, reflexive. If we know our triangle is isosceles, we know that its legs are congruent. IS is congruent to IO. The reason, legs of an isosceles triangle are congruent. Get them tick marks in there. Next, let's go off the altitudes. If we know we have an altitude, we know right angles are going to be formed. So angle ICS and angle ICO are right angles. Definition of an altitude. When I draw those right angles in, I see it's going to spell out angle side side, so I know I want right triangles. Triangle ICS and triangle ICO are right triangles. If a triangle has a right angle, it's a right triangle. And now I can say congruency. Triangle ICS is congruent to triangle ICO by HL. Now, for my CPCTC, I'm trying to show I have an angle bisector, so let's name those congruent angles. Angle SIC is congruent to angle OIC by CPCTC. Now, if these angles up here are going to be congruent, then I know that I definitely have an angle bisector. I can say IC bisects angle SIO. The reason, if a segment divides an angle into two congruent angles, it bisects. And we're good to go. Again, the process here isn't going to be easy. In class, we're actually going to go through another example all the way through. I'm writing out the givens, the proof, the picture, and the whole proof. It's a huge, huge process, and a process you have to be patient with. So please allow yourself to be patient with this process and work through it. Have a good one.